Okay, this is the Math 11-13 Zoom meeting for Friday, April 9th. We're going to work problems out of 7.2, page 587. Going to work some more examples about using the formulas. And the formulas were on page 7.2. They were sum and addition, form addition and subtraction formulas. I wrote down a lot of them last time and showed some examples, and we'll just keep working a few more problems with them for this section for today. I guess we'll start with, say, number 5. Cosine 105 degrees. Find the exact value. Okay, so you got to split up. Split up into sum or difference of two circle values. Let's see, 105, and this can get arbitrary how you do it. Wouldn't it be, let's see, that'd be equal to like 60 plus 45, wouldn't it? Yeah. So we'll write this as cosine of 60 degrees add 45 degrees. And I'm sure you have the formulas memorized. That would go cosine of first, cosine of second, opposite sign in the middle to this, sine of first, sine of second. And so the idea of using circle values is that you would know individually what these are, and then you just got to combine them, plug them into the pieces and combine them. Cosine 60 is a half. Cosine 45 is root 2 over 2. Sine 60 is your root 3 over 2. And sine 45 is root 2 over 2. And you wind up with root 2 minus root 6, and it's all over 4. And last time I checked a bunch of these with the calculator, punching it this way in degree mode, and you get the decimal, and punch this, you get the decimal, and it should be the same thing. Maybe I'll do the first one. I don't know how much patience I'll have to check anymore. Hopefully you believe in degree mode. No. Degree mode. All right. And so we have cosine 105, negative 0.2588. And on the other side, we have root 2 minus root 6 over 4. And it doesn't matter what mode that gets punched in. Square root of 2 minus square root of 6. And I didn't put it in parentheses, so I'll have to hit enter. And then divide it by 4. And there you are. Negative 0.2588. Oops. If I put it in parentheses, I could have done it in one step and skipped the negative 1.035. That's just the top. All right. I think I worked 13 last time. Why don't we try 9, a sine of 19 pi over 12. 587 sine of a 19 pi divided by 12. Okay, yeah, so again, it's, you don't really have this memorized, and how you exactly do it is up to you, but you got to kind of puzzle out. Okay, 30 degrees is pi over 6, and that's 2 pi over 12. So I'm trying to get some combination of something that'll give me a pi over 12, 19 pi over 12 eventually. 45 degrees is pi over 4, and that is 3 pi over 12. 4 times 3 is 12, 3 times pi, 3 pi. And then 60 degrees is pi over 3, 4 pi over 12. Now I'm trying to think how to get 19 pi over 12. Just directly adding them won't do it. Trying to think. 19 pi over 12. Well, maybe I should try it this way. You got to just play around. How about 10 pi? Add 9 pi over 12. All right. Well, that would be 5 pi over 6. That's a circle value, and would be 3 pi over 4. Reduces 3 pi over 4. 4 times 3 is 12. Yeah. So in effect, a sine of a 19 pi over 12 would equal a sine of 5 pi over 6, add 3 pi. Again, you can come up, I'm sure you can come up with another combination that works. So remember, the sign on this goes sine, cosine plus cosine sine, same sign in the middle. Sine 5 pi over 6 cosine 3 pi over 4 plus cosine 5 pi sine 3 pi over 4. All right, well, at 5 pi over 6, I don't know if you've got this unit circle in your head, you're at the 30 degree into the second quadrant, your sine would be a half. 3 pi over 4, cosine would be a negative root 2 over 2. Negative root 2 over 2 plus your cosine of 5 pi over 6 would be your negative root 3 over 2, and your sine 3 pi over 4 would be a positive root 2 over 2. So you're looking at negative root 2 minus root 6 all over 4. Should be it. All right. Next section uses kind of the formula backwards. About page 587.17. We're taking a cosine of 3 pi over 7, a cosine over 21, adding a sine of 3 pi over 7 and a sine 2 pi over 21. This would match. Yeah, it goes cosine, cosine, sine, sine. So that matches a cosine. And you'd have to have the opposite sign to this. So it would match a cosine of 3 pi over 7, subtract 2 pi over 21. So you cosine, cosine second, opposite sign, sine first, sine second. Yeah. And that would go cosine of, you need common denominator 21, so 7 times 3 times 9 pi over 21 over 21. That would make cosine of 7 pi over 21. 7 and 21 3 times, that's a cosine of pi over 3. And that will make, at 60 degrees, your cosine would be a half. You should be able to punch that entire thing in radian mode and get 0.5. I don't know if you believe or want to see it done, but that's what you should get. If I've done it wrong, let me know. Try tangent formula 19. 587. tangent of 73 degrees and subtract a tangent of 13 degrees, and you're dividing by product. 3 degrees, tangent 13 degrees. That would match a tangent of 73 minus 13 degrees minus 13 degrees. It distributes on top and then over 1 plus and then the product. Yeah. And that you can see is a tangent of 60 degrees, and that is root 3. 60 degrees. You'd be at x be a half. That'd be root 3 over 2. Yeah, divide about the 2's cancel, and you're at root 3 on top. Yeah. It's just all about knowing the formulas. I know that's easy to say when you've taught it for 40 years, not quite 40 years, 33 years. Okay. How about one like verify 23, page 587. Verify a secant of a pi over 2 minus u comes up a straight cosecant of u. Well, there's no straight formula for a secant of these things. We'd have to write this as 1 over cosine of pi over 2 minus u. I could flip the other side, but I guess I'm not supposed to do things. I mean, you could. I mean, it wouldn't be. And then that, plugging in your cosine formula, it's going to go cosine pi over 2, cosine u, add sine pi over 2, sine u. Remember, the cosine pi over 2 is 0, sine pi over 2 is 1, and that's going to come up with 1 over sine u equals, sure enough, a cosecant u. Yeah, I could have written this as 1 over sine u, and that's fine. So it can go, a little arbitrary exactly how you write them out. Eventually, you come down to one of the absolute basic identities that can't be played with, and you're done. All right, then the next column has more identities. I think I remember 27. 29, page 587, 29, take a tangent of x minus pi, and it's supposed to be equal to tangent. All right, well, let's, again, I can play it sine over cosine if you wanted and use those formulas. Let's see if I can do a straight tangent formula on it, which means it was tangent x minus tangent pi. 1 and opposite sign, the product, tangent pi. Well, tangent pi, I hope you know, is 0. I don't know if you need that convinced, but there's pi. Coordinates are -1, 0, and tangent is 0 over -1, which is 0. And so tangent pi here is 0, which leaves you tangent x divided by, if that's 0 and that's 0, you're left with just 1 on bottom. Tangent x. Tangent x. Oh, I think I remember working 31. About 35. The sine of an x plus y minus a sine of an x minus y comes up twice cosine x sine y. Okay, it really is just a matter of plug and chug into these formulas and then do the algebra. And it should reduce to this because you're never going to turn this to that. So a sine would go sine x cosine y and plus cosine x sine y minus big parentheses because you're going to get two pieces. So this distributes. So it's going to go sine x cosine y minus cosine x sine y. On the other side, you still have twice cosine x sine y. All right, so I don't know if you can see the algebra here in your head, but I'll go ahead and write out a step where I'm distributing the sine. So I'm getting sine x cosine y, cosine x sine y, minus sine x cosine y, add cosine x sine y, cosine x sine y. And let's see, there's a minus, hopefully two of these terms disappear. And probably two add, double to give me this, let me see. There's a cosine x sine y plus a cosine x sine y, sure enough. So this one plus this one, double. And sine x cosine y, sine x cosine y, these cancel. So cosine x sine y cosine is twice cosine x sine y. And on the other side, same thing, twice cosine x sine y. So it's just all a matter of knowing your formulas, being able to plug and chug, and a little bit of basic algebra. Probably easy for me to say. Let's see. Could do a 37, could do a 39, 43. Why don't we try 43? This is a product of cosine of x plus y, cosine of x minus y. And on the other side, you get a difference of squares, cosine minus sine squared y. Okay, let's see. You'll never, I don't think, spread this to this. So, or at least it'd be very hard. You'd have to really play around. Let's just plug and chug and see what our algebra leads us to. So I got an extra set of parentheses there that I didn't need, but it's going to get messy. Cosine x, I'm doing this piece right here. That'll be cosine x, cosine y, subtract sine x, sine y. Now that's going to be in parentheses because it's going to, see, it's going to turn into a big foil. Each of these things go to two pieces. This comes over here. That's going to be a cosine x, cosine y, and add sine x, sine y. Equals your right side. This is right side. Okay. Yeah, remember opposite signs on a cosine. We both go cosine, cosine, sine, sine, and then opposite signs in the middle. Well, that's going to get you cosine times cosine. That's identical. So that's going to go cosine squared y. Yeah, this is going to be a bit messy here. All right, now you're going to get 4p cosine y, sine x, sine y, plus cosine x, cosine y, sine x, sine y. Well, you're going to get the same identical term with a minus sign. So it is going to cancel. Minus sine x, sine y, cosine x, cosine y. And your last piece is going to be sine squared x, sine squared y, minus sine squared x, sine squared y, equals equals right side. Must equal this. All right, you can see all of this does cancel, even though it's written a little reversed, but they are identical. So that gives me cosine squared x cosine squared y minus sine equals right side. Okay, I had to study this for a second. This is tricky. Probably should not be begging me to put this one on the test. But notice how you got your cosine squared x matching that. And you got your sine squared y matching that. But there's nothing you can factor out or anything. You got to get rid of this cosine squared y and sine squared x. And the only way I can really think to do that, leave this cosine squared x, write that as 1 minus sine squared y. Minus, now you got to get rid of the sine squared x, and that's 1 minus cosine squared x times sine squared y. Again, just practice. I had to pause the recording and think about it, how to go further. So this is the only thing I can think of to do. And now we got to distribute here, distribute this. And I hope our terms will cancel out and finally give us that. Cosine squared x sine squared y minus 1. I'm sorry, not minus 1. You're distributing from the backside. Minus sine squared y plus cosine squared x sine squared y equals your right side. So you're getting minus sine squared y, and then negative is positive, and then write these two together. And your negative cosine squared x sine squared plus, boom, boom, and here's your cosine squared x minus sine squared y, which is equals there. So I can write out one more step. 1 cosine squared x minus sine squared y equals, boom, your other side. These are not 11s. I'm trying to show right side. Okay, yeah, tricky one. Let's see, jump down a couple more sections to go here. How about one like 49? Sine of arctangent x, arctangent y, right in terms of x and y. All right, well, that will go sine first, arctangent x, cosine second, same sign in the middle, cosine arctangent x, sine second arctangent y. Once again, you want number 1, 2, 4. It's a matter of draw triangles and get the formulas for them. So we need a triangle. They're matched by the angle, so we need a triangle for piece 1 and 3. So 1 and 3. So arctangent x, this is arctangent x. It's x there, 1 there, square root 1 plus x squared. Piece 1, a sine, is x over square root 1 plus x squared. And piece 3, a cosine, is 1 over the square, equals 1 over the square root 1 plus x squared. So for 2 and 4, that that triangle has arctangent of y. Y there, 1 there, square root 1 plus y squared. All right, and it's piece 2, its cosine is equal to 1 over the square root 1 plus y squared, and it's piece 4, its sine is y over the square root 1 plus y squared. Okay. See if you can match the pieces plugging in. Plug in. All right, you're going to equal, let's go on to the next page. Piece 1. Sine was x over the square root 1 plus x squared. Piece 2, 1 over the square root 1 plus y squared. That's piece 2. We had a minus sign in the middle. Piece 3 was 1 over the square root 1 plus x squared. And piece 4 was your sine y over the square root 1 plus y squared. Get an answer here, just collapsing this together. X times 1 is x over x squared, square root 1 plus y squared, minus y, minus and then y, and collapse it to the same column. It's got the same identical denominator, so you just write x minus y over that. All right. Next page, about 53. Tangent of arc sine of 3/4, arc cosine of 1/3. And again, you could always bust it into a sine of this over a cosine and work it that way, but it seems a lot longer. Let's use the straight tangent formula. Tangent of arc sine 3/4, tangent arc cosine of 1/3 over 1 plus product. 4's tangent arc cosine. All right, we are going to need a triangle. Call this piece 1, piece 2 for piece 1. And arc sine of 3/4, that'll put 3 here, 4 on the hypotenuse, making this a square root of 7, I believe. 16 minus 9 is 7, square root. This is arc sine, 3 opposite, 4 hypotenuse, making that the square root of 7. Your tangent, 3 over the square root of 7. You go to piece 2, arc cosine 1/3. I put 1 there and 3 there. 9 minus 1, that makes this a square root of 8. Your tangent would equal the square root of 8 over 1, which is the square root of 8. Plugging and chugging. Tangent here, this tangent of arc sine 3/4 would be 3 over the square root of 7 minus square root of 8. 1 plus 3 over square root of 7. See, it shows up here. And times square root of 8. Now, good luck trying to match the answer in the book. Probably get common denominators of square root of 7. So you get 3 over square root of 7 minus square root of 8 over the square root of 7. And you have to put a square root of 7 up here. you'd have square root of 7 over square root of 7 over there, 1 up there, plus 3 square root of 8 over square root of 7. You wind up with 3 minus square root of 56 all over square root of 7 over square root of 7 and 3 square root of 8 all over square root of 7. And can you see? 3 minus square root of 56 over square root of 7 times square root of 7 over square root of 7, add 3 square root of 8. Those cancel. And so you get 3 minus square root of 56 over square root of 7, add 3 square root of 8. Surely they won't make you rationalize on that. Oops. Let's see how close that got. And check many of these. Of course, we always use a calculator. 7,253, wouldn't it? Well, I must have really simplified stuff down. I got in the 3 minus. Okay, I see what they've done. They simplified these roots. All right, book. As 3 minus 2 root 14 over root 7 add 6 root 2. Okay, let's see if I can get there. See, I got the 3 minus and I get the root 7 plus. So they simplified these roots. 3 minus, I believe you're going to have 4 and 14 there. Square root of 4, square root of 14. 7 and 3, and root 8 is root 4, root 2. Well, there your root 4s cancel, which you could write down 2s when we cancel, but your root 4s right angle, they cancel. No, they don't. God, you idiot. You can't cancel because you get the plus and minus signs. Come on, you're going too fast. 3 minus root 4, root 14, and then you got, that's a minus. All right, then you got a root 7, add 3, root 4, and root 2. You cannot cancel the root 4. God, basic algebra. So there is 3 minus 2 root 14. There's your top. Root 7, and then this is a 2. So 3 times 2 is your 6. Add 6 root 2. Bingo. You finally quit. If you really wanted to be mean, you could rationalize this bottom. Take another 2 pages of algebra to rationalize the bottom, but they decided not to. All right, let's see. What do we got? One more, maybe. Why don't we try 57? A57. Line of a theta plus phi. Remember, we're working 55, and it got pretty complicated. Okay, they don't really number these out, so you got to really interpret this gibberish. It's basically, you call it situation 1. Sine theta is 5 over 13. And you're in quadrant 1. Situation 2 is that cosine of phi is negative 2 root 5 over 5. Phi's in quadrant 2. Okay. We're going to expand out, expand. So we know what we're plugging and chug. It's really plug and chug. Our sine of theta plus phi. So we know what we're plugging and chugging into. We'll have 4 pieces. We'll number them 1, 2, 3, and 4. And we'll see if we can't puzzle out those 4 pieces. All right. So it is equal to a sine, cosine, plus cosine, sine. Okay, we'll number 1, 2, 3, and 4. Okay, go to triangle 1. Here, where sine theta is 5/13, quadrant 1. It's 5, 13, and can you tell that's 12? 169 minus 25 is 144, square root is 12. Everything's positive, it's quadrant 1. All right, so that gives us piece 1, sine theta is directly 5/13 over 13. That was given. I don't know this piece till I do the second triangle. Cosine that, no piece 3, your cosine will be 12/13. Now, write down your cosine of theta is in 12/13. All right, go to triangle 2. Cosine of your phi is -2√5/5, quadrant 2. Okay. Cosine is adjacent over hypotenuse. Okay. I have to puzzle out this y side. So y squared plus -2√5 quantity squared equals 25. 5 squared plus 4 times 5 equals 25. Y squared plus 20 equals 25. So y squared equals 5. Y is the square root of 5. And it's positive. Is your quadrant 2. So your cosine phi was given. That's piece 2. This is directly -2√5/5. You can see it from here, yeah. And then your sine phi is √5/5. So that's as compact as I can do it. Plugging in all 4 pieces. Okay, so if we can clean up these pieces, it looks like you got a -2 times 5, -10√5/65. 12√5 and those wind up being like terms, so that looks like 2√5 divided by 65. Let's see how close that gets. 7/357. 7/257. My apologies. 7/257. Oh, it's way off. 7/257. 2√5/65. Bingo. See that? 2 square root of 5 divided by 65. All right, well, that'll finish this Zoom meeting. That's about most of the examples of the odd problems that I can give you out of 7/2. Quiz 10 over is now available. And due Sunday for 11. All right, hope some of this helped. We'll see you next week for Thrilling 7/3. 3 sections to go. Go. 3, 4, and 5. And this semester's in the history books. See you next week. Thank you.